Ji, Assalamualaikum. This is Dr. Shoukat, and today we are going to discuss a little bit about the very commonly encountered in the ward situation and HDU situation regarding the hyponatremia. Is Take example if patient has presented with or admitted with the serum sodium of 110, and here you can see in the first one example over here where we want to get the sodium deficit. So if the patient admitted 110 sodium and my desired sodium is 120, then I need to take the deficit. So I have to minus from 120 to 110. Suppose patient sodium is 110, we already discussed. And here the 40 is basically the assumed total body water. Suppose someone who admitted weights around 70 to 70 something, but suppose the total body water which comes out as a 40 kg, and it varies from the male to female gender. When we take the total body weight into the total body into the zero point 0.6 in case of male and zero point 0.5 in case of female. But suppose we get it out and it turned out to be 40, then the sodium deficit comes out as a 400 milliequivalent, or here you can see. So this is the just getting the deficit of the sodium in the body. It suggests when you infuse 400 milliequivalent sodium, then it will increase the serum sodium up to this level 120. Now in second step, we want to see the change in sodium. When we want to see the change in sodium, then we have to give sodium in the body. Suppose in this patient, if the hypertonic saline has to be given, and we know that 1 liter sodium, 1 liter hypertonic saline, the sodium contains 513 milliequivalent, and the patient sodium is 110. When we minus 513 and minus 110, which is a patient sodium, and divide it with the total body water plus 1, as this is the formula given in device formula. So it makes 9.8 milliequivalent. This is change in the sodium basically. Now here you would ask, why do we put 1? The 1 has been put because we give 513 sodium in 1 liter, means 1 liter extra water goes into the body with the actual total body water which we took as a 40. Now 1 extra, so we have to give 1 plus 1. Now in case the patient is making urine 1 liter, so you can see in third example over here, if patient making 1 liter urine and the urine sodium is 40, then you have to put the values like this. 513 is the saline we infuse, minus 110 is the patient's serum sodium, plus 40 we add because the 40 has been lost from the urine. So we add that into the 110 and minus this figure from 513 and divide it 40, not 41, because 1 liter has been excreted out. When you give 1 liter, 1 liter excreted out, then it has to be the 40. And when you minus this figure, 110 is serum sodium and plus urine 40, then it turns out to be the 513 minus 150 divided by total body water, that makes 9 milliequivalent, means the change of the sodium would be 9 milliequivalent, not 9.8. 9.8 was a bit raised because we took the example where no urine was coming out into the no sodium was coming out into urine, so that was example matched over here. But usually patient makes some urine and excretes some sodium from the body, so that has to be added in that. So in this way we can calculate the change in sodium, and in this way we can calculate also what is the total deficit. And this plan is actually made for the 24 hour. It means that was desirable sodium in 24-hour period. After the 24-hour, if we see the change comes to that or this, are little bit not up to our expectation, then there might be some reason. But the next plan, next 10 to 24 plan would be accordingly. So hope this makes your concept bit clear. Thank you very much for giving attention.